solving trigonometric equations often takes a little more patience and creativity than a normal equation. Normally I would try factoring first, right? Normal algebra and factoring skills, but that's not going to work with this one. Take a look at that. There's a sine function and a cosine squared, and there's no GCF or big X type factoring that you can do with this. So instead, we're going to start working down our list of other options. Normal factoring is not going to work, but multi-angles isn't going to work either, because if you look at this, that's a single angle, that's a single angle. So there's no 2 beta that I can work with here. We keep working down the list. There's a Pythagorean identity. Now that's useful, because that allows me to rearrange this equation as the following. 5 plus sine beta equals 6 times, if you think about the Pythagorean identity for cosine squareds, that's 1 minus sine squared beta. Okay, and now I'm pretty happy because there's only sines left in this. Sine of beta squared. So let's simplify this out. Okay, I'm going to distribute the factor of 6 on the right side. So it becomes minus 6 sine squared beta. And now I'm going to go back to the original steps that weren't working before. Let's see if we can factor this one. So I'm going to move that 6 sine squared over to the right side, because I have a preference for always having a positive quadratic. That makes the factoring easier. We're less likely to mess it up. So I've got 6 sine squared beta plus 5 sine beta. And then when I subtract that 6 over, it's going to leave me with a plus 1. The factoring I'm going to leave for you to do. If you want to spend a little time with U substitution, convincing yourself that this works, or a little time guessing, great. But we're going to leave that as a student exercise. I would caution you, though, make sure you're very careful about the factoring and check to see that it works. Because if you mess up the factoring, right, if you don't check this step and confirm that your factoring was correct, woo, you're way off. There's no way you're going to get the right answers after that. So let's go back to this and solve each of these things separately. You can see how sine of beta is going to quickly turn into negative 1/3 from the factor on the left, and the factor on the right is going to give me sine of beta equals negative 1/2. Well, I can solve those without I can solve one of them without too much difficulty. If you think about the unit circle, right, here's my unit circle. Where is negative 1/2 in the y coordinate? Well, that's kind of here-ish. Okay, somewhere around here. So for this guy, for sine of beta equals negative 1/2, no problem. I know those angles are, let's see, that's going to be 5, nope. It's going to be 7 pi over 6 and 11 pi over 6. Those are my two answers. And I can put those into this box. However, there's more. That's only the sine beta equals negative 1/2. I also have this sine beta equals negative 1/3 thing. And that is not something you're going to recognize on the unit circle. It's not DNE, right? The negative 1/3 spots, let me put those in red here. The negative 1/3 locations on the unit circle are just going to be nearby the negative 1/2 locations, but not quite. And they're certainly not a special angle, but they are an angle. So the way you have to write these things is the following. Instead of saying in the first step where I said, beta equals these nice special angles, now we're going to have to deal with angles that are not so nice and special. So what you do is you just say arcsin, right? This is you basically throwing up your hands and saying, well, I don't know exactly what that angle is, but the best I can do is arcsin negative 1/3 and let the calculator worry about it. Not that we're going to use a calculator in this problem. Oops, started getting ahead of myself there. So there's two angles here. One is the arcsin of negative 1/3. The other is, as always, when you're dealing with sines, it's going to be pi minus the arcsin of negative 1/3, right? The first angle put into this pi minus situation. And we just need to modify this a little bit more because one of those is a negative, right? This first one that I wrote. So I'm going to have to say beta equals 2 pi plus the arcsin of negative 1/3 on that first one, because the arcsin of negative 1/3 is negative. We can't have that. And then my second one is unchanged because that is a positive angle, which you can confirm in your calculator. Although you should have a a pretty good sense for these things, like where arcsines would lead you on a calculator, so you don't actually need it.